All right, I'm back. Sorry about that. I don't know what the deal is. My computer likes to just stop recording sometimes. So I believe we were. I didn't get too far before I realized it happened. So basically, you guys should have seen this entire problem set up. You get that we're doing a rectangle minus a bunch of pieces. We're doing a rectangle minus a piece that is a rectangle, and then minus three pieces that are triangles. So you see all that work. And all that comes out to 40 minus 31.5, which leaves you with 8.5. So this problem is done. We can go to 6 now and hope that my computer doesn't play any more games. So looking at 6. Number 6, we're moving away from the geometry and we're getting a little more algebraic now. Hopefully you're comfortable with that. But looking at this, if this here was a line called A, and if this here was a line called B, then hopefully it's obvious to you that the slope of line A was just 5/8. We're already in that y equals mx plus b form. So we can just see that our slope is the coefficient of x, which is 5/8. And the slope of line B, well, that line is in y equals mx plus b form too. So we know that its slope is just the coefficient of x, which is negative 8/5. And then all you got to do to decide if we're parallel, perpendicular, or neither, parallel, perpendicular, neither, well, we're parallel if the slopes are the same. These are obviously not the same. We're perpendicular when our slopes are opposite reciprocals. That's what these are. Opposite means one of them is positive, that's this one of them is negative. These are opposites. Also, they're reciprocals because one of them is 5/8 and the other one is 8/5. So you should be able to say the lines are perpendicular because the slopes are opposite reciprocals. That's it for that one. Going on to the next one. If this was a line called C, and this is a line called D, well, equation C is solved for y. It's in the y equals mx plus b form. So you already know the slope of C is the coefficient of x. So that slope is -2. But looking at line D, we are not solved for y. So I'm not sure what our slope is. It's not the coefficient of x unless you solve for y and get into the right form. So we know that for this problem, we better take this equation and we better do some algebra on it. So the 6x minus 3y equals 9. That equation isn't worth much to us. So let's solve for y. And let's solve for y by subtracting 6x from both sides. That'll cancel those. We now have negative 3y. Don't lose the negative. It has to still be negative 3y. Also, don't write this as 9 minus 6x because we want it to be x's first. So let the 6x go first and then just do a plus 9. Then, to isolate y, you better divide through by -3 on both sides. That's going to cancel those, giving us plain old y. Now over here, make sure that both of these get divided. So this divides by -3, but that guy divides by -3 also. So we'll get, let's see, negative over negative is a positive. So this will be positive 2x. And a positive divided by a negative is a negative. And that'll be 9/3, which is 3. So that means, looking at this, from this equation we can see that our slope is 2. So how's that compare? We have one slope that's -2 and one slope that's +2. So that seems like they're related, but there's no relationship there because it would only be parallel if the slopes are the exact same. Not -2 and 2, but -2 and -2 would be parallel, or 2 and 2 would be parallel. But 2 and -2 are nothing. To be perpendicular, remember, we had to be opposite reciprocals. These numbers are just opposites, but they're not reciprocals. So here your conclusion is supposed to be that these lines are neither. We can say neither parallel nor perpendicular. All right, do the same thing over here. Again, neither of these equations are solved, so let's solve this one for y. And my advice here would be just multiply everything by 4 right away, because I don't want this fraction. So the 4 distributes onto the x, I get 4x. The 4 distributes onto the 1/4 y, and I just get 1y. And the 4 distributes onto the 3/2, giving me 12/2, which is 6. Then at this point, I just subtract 4x from both sides, and I get y equals negative 4x plus 6. And that tells me that the slope is negative 4. Now for the second equation, subtract the 20x from both sides. So you get 5y equals negative 20x plus 15. Then divide through by 5. And you'll get y equals negative 20 divided by 5 will be negative 4x. And 15 divided by 5 will be plus 3. Oops, don't circle that. That's not what I care about. We just want the slope. And the slope is negative 4. And so guess what? Since both of these slopes are negative 4, that proves that the lines are parallel. Because the slopes are the same. Exclamation point. Okay, great. So that's number 6. All right, and now it's time to be writing some more equations. So for number 7, we want to find the equation of the line described below. We want to be parallel to this line, and we want to pass through 4, negative 1. So there's 2 ways to do this. Let me do it. It's kind of 3 ways to do it, but I don't want to be here all night, so I'm not going to show you every possibility, I guess. But what do we know? Hopefully it's obvious to you that this given equation has a slope of 2, because it's in that y equals mx plus b form. So the slope is just that coefficient. Slope is 2. Now it says we're trying to be parallel. Since we're parallel, our slope has to be 2 as well, right? We also have to pass through the point 4, negative 1. So that means we've got a point, meaning an x1, y1 thing going on, 4, negative 1. So my preferred way to do this problem is to use not y equals mx plus b, although you can do y equals mx plus b. But for this problem, I like this equation, y minus y1 equals m times x minus x1. And so to use this equation, you'll plug in the given point. 4 will be your x1, so the 4 goes here. Negative 1 will be your y1, so that goes here. And your slope will be the 2 that we found, so the 2 goes here. So you'll have y minus negative 1 equals the 2 times x minus 4. So there's everything plugged in. Now that equation, that's our answer. There it is. I just want to clean it up now. I just want to solve for y. So minus minus we know becomes y plus 1. And I do want to distribute this 2. So this will become 2x minus 8. Then I just subtract 1 from both sides. Minus 1, minus 1. So you get a final answer of y equals 2x minus 9. So that's one way you could do it. And I'll show you another way. Okay, I'm back. I'm over here now. I'm over here in this corner. And I got a grid. So this is the other way that we can do these kinds of problems is if I provide you with a grid, then there might not be a heck of a lot of work for you to do because we know that we want to have our slope of 2. We still know that because we're trying to be parallel to some other line whose slope is 2. So our slope has to be 2. And we know we have to pass through the point 4 comma negative 1. So if you've got a grid, then plot that point at 4 comma negative 1. Here I am. Now the other value in our equation, you guys know that's called the y-intercept, right? And that point is literally just the numerical value of the point where you cross the y-axis. So if I can just figure out where this line goes, if my line went like this, zoop, then the y-intercept would be negative 2. If my line went like this, zoop, then my y-intercept would be 3. You can just read it off of the graph. So how does my line go? Well, the slope is 2, isn't it? And if your slope is 2, then you could put that over 1, and don't forget that that's just rise over run. So from this point that I was given, I can rise up 2 and run 1. And I can rise up 2 and run 1. Now all these points are taking me further away from the y-axis. So maybe instead of rising up 2 and right 1, why don't I rise down 2, left 1? And then down 2, left 1. And then down 2, left 1. And then down 2, left 1. Oops. Here I am, right on the y-axis. So having drawn all those points, you don't even have to do this, but you could now just connect the dots. And that blue line is our line. It's got the right slope. It passes through the right point. It passes through the point that we were given. The point that we were given being 4 comma negative 1. And we can straight up just see with our eyes that our y-intercept should be negative 9. So that's it. We would know that our equation is y equals 2x, because our slope has to be 2, minus 9, because we pass through the y-axis at negative 9. So that can be a very, very easy way to do these problems. But it doesn't always work. So make sure you know how to do it algebraically as well, just in case. All right, that's 7. 8. Should look pretty similar to you guys. The big difference here is this time is our equation solved for y? No, it isn't. So we should take that equation that we were given and we should immediately solve it for y, which means subtracting 3x from both sides. So you'll have 2y equals negative 3x plus 10. And you'll have to divide through by 2. So you'll get y equals negative 3 over 2x plus 5. So that means the given line has a slope of negative 3 over 2. So what does that make the slope of the line that we're trying to write? Well, we're trying to be perpendicular. So that would make our slope the opposite reciprocal, which would be positive 2 over 3. So that means now the only slope that matters to us is positive 2 over 3. You can basically forget about this slope now. And we want to pass through 9, 4, right? Let's not use algebra. Let me go back and get my grid. Or do I already have my grid? Paste. Boop. Nope. Boop. Copy. Boop. Paste. Now the point that I need might not be on the grid because I don't know. We'll find out together. It'll be an adventure. So here's my grid. It says I'm supposed to pass through the point 9, 4. Is that at least on the grid for me? It is. 9, 4 is right there. Our slope is 2/3, so that would be a rise of 2 and a run of 3. So again, I could rise up 2 and right 3, but that's not the way I want to go. I want to be running back towards the y-axis. So instead of going up 2 and right 3, we could go down 2 and left 3, because negative 2 over negative 3 is really still a positive. So I'm going to go down 2, and I'm going to go right 3, and this point is a point on my line. Then I can go down 2 over 3. Then I can go down 2 and over 3, and look at that. My y-intercept is negative 2. So we're done. The equation of the line that we're trying to write is that it should have a slope of positive 2/3, so 2/3 x, and it should have a y-intercept of negative 2, so minus 2. So I had to do a little bit of algebra just to put the given equation into y equals mx plus b form, just to find the slope so that I could take the opposite reciprocal to find our new slope. But then I didn't have any algebra left to do. All I was doing was plotting points in the coordinate plane so I could figure out where I crossed the y-axis. Okay, that's still going to be my preferred method. Now if you wanted to, could you do this problem the same way that we did number 7 by using the y minus y1 equals m times x minus x1 equation? Sure, you could. And that algebra will work. And if anybody wants to see that, you can ask me about it tomorrow in class and I'll show you. 9. 9 says, find the equation of the line that's described below. Okay, fine. Hopefully you remember from the last two problems that the first thing we did was to try to find our slope. Now in the last two problems we found our slope by just looking at the equation. In number 7 the slope was 2 because that was the coefficient of x. In number 8 the slope was positive 2 over 3 because we wanted the opposite reciprocal of the coefficient of x in this equation. In number 9 we don't have an equation, we just have 2 points. And that's fine because we know there's a formula for slope. Slope is m, slope is rise over run. But there's one other formula for slope that says you just do y2 minus y1 divided by x2 minus x1. So if you have 2 points, then you use this formula. And our two y values are 14 and 4, so in the numerator I'm going to go 14 minus 4. And my two x values are 2 and negative 2, so I'm going to do 2 minus negative 2. So okay, 14 minus 4 is 10. And 2 minus negative 2 is 2 plus 2, so 4. These are both divisible by 2, so 10 divided by 2 is 5. 4 divided by 2 is 2. So our final answer here would be that our slope is 5 over 2. Now from here I would say, I guess we could graph again. We could pick one of the points and we could use the 5 over 2 to plot points, but let's do the algebra one more time. The algebra says we'll use y minus y1 equals m times x minus x1. And that means we've got y minus. Now who's y1 and x1? You could literally pick either point. I'm going to use this one because both coordinates are positive. But if you were to use this one, you'll get the same answer. You can use either point. It doesn't matter which. But like I said, I'm going to use the 2 and the 14 because they're both positive. So that means I'm going to subtract 14. My slope is 5 over 2. And then x1 is my x coordinate. You have to use the same x. If you're using 14, you have to use 2. So be careful you don't say negative 2. So we're going to go with 2. All right, now what? Just clean this up. This will be y minus 14. Distribute the 5 over 2. This will be 5 over 2x. Then 5 over 2 times 2 will be what? 10 over 2? So 5? Yeah. Then you're just gonna, whoopsies. Then you're just gonna add the 14 to both sides. That'll cancel. You get a final answer of y equals 5 halves x plus 9. So that's the answer to number 9. And then I think we've only got one more. So let's do 10. So for number 10, you've got a graph to look at, which is good. It says find the equation of the line described below. We want to be perpendicular to the line that we see, and we want to pass through negative 3, 5. Still, the first thing you should do is find the slope. So the first thing you'll do is you'll find the slope of the line that you're given. So there's a couple of dots here. Maybe you can see them. There's a good dot right there and right there. So I'm going to use those two dots to find our slope. I'm rising 1, 2, 3, 4, and I'm running 1, 2, 3, 4, 5. Yeah, so that means the slope of the line that we're given is 4 over 5. But that's not the slope of our line because we're trying to be perpendicular. So our line then should have a slope of negative 5 over 4. Okay, what else? We're supposed to pass through negative 3, 5. Where's that? Negative 3, 1, 2, 3, 4, 5. We're supposed to pass through that point there. All right, what do we do now? Well, we use our slope. And our slope could be negative 5 over positive 4. Or you could treat it as positive 5 over negative 4. If I do this, then I should be dropping down by 5 and then running 4 to the right. So from here I'll drop down 1, 2, 3, 4, 5, and I'll run 1, 2, 3, 4 to the right. So here's an example of a problem. This is my line. It passes between those 2 points, and I can't really see where I'm hitting the y-axis. I'm hitting the y-axis somewhere between 1 and 2, but it doesn't look like it's 1.5. Maybe it's 1 1/4. Maybe it's 1 1/3. I don't know what it is. So this is one of those times when you really can't use the graph. We're going to have to fall back on algebra, which is fine because we practiced. We know what to do. We know that our equation is y minus y1 equals m times x minus x1. And we know that this ordered pair is our x1, y1. And we know that our slope is the negative 5 over 4. So we're going to go y minus our y coordinate, which is 5. Our slope is negative 5 over 4. X stays x, but x1 becomes the negative 3. So we just have to clean this equation up now. This side will stay y minus 5 for the moment. And I'm going to distribute this, so I'll get negative 5/4 x. And I'll distribute that onto this. This is going to be plus 3. So times a negative is going to be minus. This 3 is basically 3 over 1. And when you multiply the tops. So I'll get 15 in my numerator. And I'll get 4 in my denominator. So this is where I'm at. Now I just have to add 5 to both sides. So I'm going to get y equals negative 5/4 x minus 15/4 plus 5. And so hopefully you remember that to add these two whole numbers, well, they're not whole numbers, this guy's a fraction, but to add a fraction and a whole number, I need a common denominator. So I basically just want to express this 5 as a fraction whose denominator is 4. So I'd have to multiply the bottom by 4. But if you multiply the bottom by 4, you have to multiply the top by 4. But basically I end up with y equals negative 5/4 x minus 15 over 4 plus 20 over 4. But now that these two fractions have the same bottom, I just have to add the tops. So negative 15 plus 20 will be positive 5. So that's kind of annoying, but the y-intercept will be the same number as the slope. That's kind of uncommon. That's just a coincidence. But we're going to get negative 5/4 x plus 5/4. And that should be the answer to number 10. And that's it. Oh, good. I thought that I stopped recording, but no, we're good. That's the whole quiz. Your quiz is going to cover these algebraic problems having to do with writing equations. Maybe you'll have a grid to look at. Maybe you'll have a grid to use. If you don't have a grid to use, then you'll have to use algebra. And my strong advice is to just use this equation, the point slope form. What else did we do? We had equations where we decided if we're parallel, perpendicular, or neither. But the other big deal was finding area. Ooh, I forgot we had to find perimeter too. That's my bad, y'all. We better do this problem, huh? But the other thing was classifying triangles. So we found all the side lengths and we classified. We used our side lengths to check the values to see if we were right acute obtuse. But that's the whole quiz. These few objectives are all you have to worry about. And if you're still here and you thought you were done and you thought you could tune out, I guess you can't, because I forgot to find perimeter for number 5. So let's do it now. So for number 5, let's take all that good stuff and I'll shrink it down. And we'll do a little more math. We need our perimeter. So to find the perimeter, we need the lengths of all three sides. Luckily for me, we kind of have it already. Let's call this point A and this point B and this point C. So in blue, we can see AB. We already talked about how to find side AB. It's just Pythagorean theorem, basically. It's going to be the square root of this side, that looks like a 9, but it's actually a 4. But we're 4 by 3, so you'll go 4 squared plus 3 squared. That's going to give you a 16 plus a 9. That's going to be the square root of 25. And square root of 25 is exactly 5. So don't leave it as a radical. Give it to me as a whole number if you can. In orange, that's BC. So that's going to be the square root of those two sides, which is 1 by 5. So just 1 squared plus 5 squared. That's just going to be 1 plus 25. So that's going to be the square root of 26, which is just a little bit bigger than 5. And then we've got in red the bigger one down here, and that's AC. But those sides are what, 8 and 5? No, 8 and 6. This side is 6. So that's going to be 8 squared plus 6 squared. And that's another one that comes out cleanly, because this is going to be 64 and 36. That's going to be the square root of 100. And the square root of 100 is exactly 10. So there's your three sides. So the good news is to find the perimeter is a piece of cake. Because the perimeter is just the sum of all sides. And sum just means add them up. So I guess we're going to do 5 plus root 26 plus 10. And you can just use a calculator to figure out what that is. I'll just use the one on my phone. But it's just going to be 15 plus whatever the square root of 26 is. So square root of 26 is 5.099. So if you add another 15 to that, that's 20.099. Oh 9901. You guys know I want you to round to 2 decimal places. So this 9 would bump this 9 to a 10. So technically you're going to get 20.10. So 20.10. And hopefully you remember me saying that if this last digit is a 0, you do still include it. If you cut it off, it's going to look like you rounded to only 1 decimal place instead of 2. So don't. And since this is perimeter, these are going to be units. Not square units, just regular old units. But there you go. Sorry I forgot to do the perimeter before, but up here, small, we've got our area. You can just go back to the end of the first video is where I did all that math for the area. And that the first video got cut off, but if you need this math, it's at the end of video 1. And now we've got the perimeter too. So finally we're done. I'll see everybody tomorrow. Again, if this video helps you, you should tell me that, because I hate making them. So if you want me to keep making them, you need to tell me that this was helpful. Otherwise, I'm not going to do it. Anyway, have a great night. See you tomorrow. Bye.